All right, so what we're going to do in this video is look at factoring quadratic expressions. And there's really just three types of quadratic expressions I'm going to focus on in this video. As you can see here, trinomials whose leading coefficient is 1, trinomials whose leading coefficient is not 1, and then we're going to look at a difference of squares. So with a quadratic expression, again, you see here the ax squared plus bx plus c. Again, the a, b, and c are real numbers where a is not 0. Now, if a, b, and c, if none of those are 0, then we have what we call a trinomial. A trinomial is a polynomial that has exactly 3 terms. So you can see here, you got ax squared, that's one term, bx is the second term, and c is the third term, right? And it's going to be just a little easier to factor if the leading coefficient, which is the coefficient of the x squared term, again here the a is what we call the leading coefficient, if that is 1, it's going to be easier to factor. And so that's sort of where we will start here. Now, for us to really understand how we're going to factor a quadratic expression, specifically the trinomials, we need to understand how to multiply two binomials together. So you may have learned the box method, FOIL method. I'm just going to look at the FOIL method here. So just kind of go over this real quick. If we're multiplying two binomials together, so let's say we have a plus b times c plus d. So the FOIL method, the f stands for first. So what we're going to do, is multiply the first terms in each factor together. So here we're going to have a times c, which will give us ac. The o stands for outside terms. So the a times positive d, so that's going to be plus AD. I is for the inside term, so positive b times c, so it's going to be plus BC. And then last, the L in FOIL stands for last term, so positive b times positive d, and so it's going to give us plus BD. All right, so that's the FOIL method. And I want to look at two specific examples where we're just are multiplying two binomials together, and this is going to help us to understand the difference between when the leading coefficient of our trinomial is 1 and when it is not. So again, I've already got this worked out here. So in this first one, x plus 3 times x plus 6. So when we multiply first together, x times x will give us the x squared. Outside, x times positive 6 will give us this plus 6 here. Inside, positive 3 times x is the positive 3x here. And then last, 3 times 6 will give us the 18. Right? And so and we are going to combine the like terms in the middle. 3x plus 6x is 9x. But what I want you to notice, again, you see here the coefficient of x squared after we multiplied is 1. You don't see a number there, it turns to be 1. But when the leading coefficient's 1 here, right, the leading the coefficient of the x's in our factors here are both going to be 1. And when that's the case, when we do the outside, which was 6x, and the inside, which was 3x, these coefficients of x here are going to be the same as these numbers here in the factors, right? And what I want to understand is that when we go to factor, because when we go to factor, we're going to start with something like this, x squared plus 9x plus 18, and we're going to try to rewrite it as x plus 3 times x plus 6, right? The first terms when we go to factor have to multiply to be the leading term here, the x squared term here. The last terms have to multiply to be the constant term here, the positive 18. And when the leading coefficient's 1, you can see here, they're also going to, the 3 and the 6 here, the last terms are going to also add together to be the coefficient of this middle term. Now, when the leading coefficient is not 1, that's not going to happen. That last part where those numbers also add together to be the coefficient of the x. And you can see here in this example here where I've got 2x plus 3 times x plus 6, right? We multiply first terms together. 2x times x is 2x squared. Outside, 2x times 6 is positive 12x. Inside, positive 3 times x is positive 3x. And last, 3 times 6 is 18. Combine the like terms in the middle, and we get plus 15x. Now, what I want you to notice, the leading coefficient here is not 1, it is a 2. The coefficient of x squared is 2. And so when we go to factor this, right, the first term in each of these factors is going to have to multiply to be 2x squared, right? So as you can see here, the coefficient of x in these factors, they're not both 1. This one here is a 2. And what that's going to do, when I multiply it outside, I said 2x times 6, I got 12. So you can see these two middle terms before I combined them, the coefficients were 12 and 3, which are not the same as these constant terms in the factors. So when we go to factor, the first terms in the factor have to multiply to be 2x squared. The last terms also have to multiply to be positive 18. But when the leading coefficient is not 1, the numbers are not going to add together to be this plus 15, the coefficient of the x. And so when the leading coefficient is not 1, we're going to kind of have to use trial and error, or may call it try and check. All right, so let's look at our first example here. All right, so we have this quadratic expression, and this is a trinomial. It's got 3 terms, x squared minus 4x minus 45. Now, the first step in any factoring problem is find the greatest common factor. Right? If the greatest common factor is 1, you just go ahead to your next step. If the greatest common factor is anything other than 1, well, then you need to factor it out. All the problems we're going to look at today in this video, the greatest common factor is going to be 1, so that we can focus more on factoring these trinomials, factoring how do we factor a quadratic expression. Right, so what I'm going to point out is the leading coefficient here is a 1. Right, look at the x squared term. The number in front of x, you don't see 1. It's there's technically a 1 there, and if you want to write it there, you can. You don't have to, but that leading coefficient is 1. So this is going to be a easier problem to factor. And so what I'm going to go ahead and do is draw my 2 parentheses, and again, each parentheses is going to contain a binomial, 2 terms. Now, what we know is the first terms in each parentheses, when we multiply them together, thinking about FOIL, they need to multiply together to be the first term, the x squared term here. Right? So since the coefficient is 1, the only 2 whole numbers that multiply together be 1 or 1 and 1. So 1x and 1x multiplied together gives us the x squared. Right? So we'll put x here and x here. Now, the next thing we know is that the last terms in each of these parentheses have to multiply together to be the constant term, negative 45. So they're going to multiply to be a negative, so they need to be opposite in sign. One needs to be positive, the other needs to be negative. Right? Now, we also want the numbers, because the leading coefficient is 1, the numbers to also add together to be the coefficient of the x term, negative 4. Right? So you kind of, and what I do sometimes is I list out all the ways to multiply 2 integers and get negative 45, and then I take those integers that I have and see which pair will also add together to be negative 4. Right? Now, kind of going through that, we can see what it's going to turn out to be is negative 9 and positive 5. Right? Because if we multiply negative 9 times 5, we get the negative 45, the constant term. And if we add those two, negative 9 plus 5, we get negative 4, which is the coefficient of the x term. Right? So the numbers that are going to be the last term in each of these factors, each of these parentheses, negative 9 and positive 5. And it's important to get the signs correct. Now, the order that you put these in does not matter. You can put the negative 9 in the first parentheses and the positive 5 in the second, or vice versa. It does not matter. Right? And if you want to FOIL that back out to check it, you certainly can do that. So now let's look at an example where the leading coefficient is not 1. All right, now you may have learned a bottoms-up method or some other method to kind of make this, maybe shorter or maybe easier for you. I'm just going to do trial and error because, again, it just revolves around the fact of knowing how to FOIL. Right, so what I know, again, the GCF is 1 here, so I'm going to go ahead and draw my 2 parentheses. Now, what I know is the first terms in the parentheses have to multiply together to be the 6x squared. Now, we've really got 2 options here, right? Either 1x and 6x. 1x times 6x is 6x squared, or, or I keep hitting the next slide button, sorry. Or we could do 2x times 3x, which will give us 6x squared. Right, so we have 2 options up front, and so what we have to do is just pick one to try, right? So I don't know which one's going to work. I'm going to try 2x and 3x. All right, now the next thing I know is that the last terms in the parentheses have to multiply to be this constant term, negative 10. Right, so there's some options here, and I'm going to write these all down, right? Again, they got to be opposite sign to multiply to be a negative, right? So negative 1 times 10, positive 1 times negative 10, negative 2 times positive 5, or 2 times negative 5. These are the 4 ways that we can multiply 2 integers and get negative 10. Now, because leading coefficient is not 1, they're not going to also add together to be the coefficient of the x term, the positive 11. Right? We just need to pick one of those 4 to try, and we do it. We FOIL it out, see if it works. If it doesn't work, we swap which parentheses are in and try it again. And we go through this process until we've exhausted every possibility, until we get one that works, right? So I'm going to try, let's try 5 and negative 2, right? So I'm going to try it with the positive 5 here and the negative 2 here, right? And I'm going to check, I'm going to FOIL and see if it works. So if I do first terms, I get 6x squared. Outside, 2x times negative 2, it's negative 4x. Inside, positive 5 times 3x, that's positive 15x. And then last, 5 times negative 2 is negative 10. And then I'm going to combine the like terms in the middle and see if I get the positive 11x that I want, and I do. Now, if I didn't, right, well, then I would try to swap them. Maybe the 2 should go in the first parentheses, 5 go in the second parentheses, and then try that. Now, swapping the signs, the only thing that would do, if I made it 2x minus 5 and 3x plus 2, if I just swap the signs, all it's going to do is change the sign of this 11x here. So if that was a 2x minus 5 times 3x plus 2, that would just make this minus 11x. The number would still stay the same. It would just change the sign. Right? So when the leading coefficient is not 1, we just have to use trial and error. We're just going to try our options and keep trying until we get one that works. Now, the very last thing I want to go over real quick is the difference of squares. Right? So if you have subtraction between 2 squares, right, numbers that we know the square root of, that simplifies down to a whole number, this is the way that we're going to factor it. So if you have x squared minus y squared, that factors as x plus y times x minus y. So if we look at this example here, we have x squared minus 36. Now the first thing to note, again, it's not going to be a trinomial, it's going to be a binomial, so it's going to have 2 terms. And it's got to be subtraction. If it's a plus, it's definitely not going to be a difference of squares. Difference means subtraction. So if you notice, this first term is x squared. That's a square. And the second term, 36, we can write as 6 squared. So it is also a square. And I'm going to write it. You don't necessarily have to rewrite 36 as 6 squared, but I'm going to do it so we can see clearly. So it's going to factor into 2 factors. The first term in each is going to be the first term, what's being squared, x, One's going to use plus, one's going to use minus, and the last term in each, what's being squared in the second term, 6.